Sketch the limacons, the snail, curve by r equal to cosine of theta minus 1. Since f of theta equals cosine of theta is periodic, we only need to plot points between negative pi and pi. We then use symmetry to obtain the rest of the graph. The first step involves plotting the points. To obtain the points, we plug in the angle theta into the equation to obtain the radial coordinate r. For example, if we plug in 0 into theta, then we have 2 cosine of 0 minus 1 is positive 1 because cosine of 0 is 1. 2 times 1 is 2, 2 minus 1 is 1. Cosine of pi over 2 is 0. 2 times 0 is 0. 0 minus 1 is negative 1. And cosine of pi is negative 1. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. We then plot these points in the polar coordinates, even though we have the xy coordinates set up. To keep track of the points, we're going to label these as A, B, C, D, E, F, G. At the point A, the angular coordinate is 0 and the radial coordinate is 1. So this is A. At B, the angle is pi over 6 and the radial coordinate is 0.73. We would go to the ray pi over 6 and we would stop at a distance of 0.73. This is the point B. At the point C, we would go to the rate pi over 3 and stop at the distance 0, which is at the origin. At the point D, the angular coordinate is pi over 2, so we would go to the ray indicating the angle pi over 2 from the positive horizontal axis. This is the positive y-axis, but the radial coordinate is negative 1, so we would go to the opposite direction. Thus, D is at this point. Notice that if we were to stop right here, then the coordinate of this point would have been 1, pi over 2. Thus, in the opposite direction, negative 1, pi over 2. For E, we would stop at the rate 2 pi over 3 in the second quadrant, but the radial coordinate is negative, so this point in the second quadrant is now in the fourth quadrant. Thus, any angle from pi over 2 to pi should be in the fourth quadrant, because pi over 2 to pi are in the second quadrant. The negative radial coordinate means we need to go to the other side in the opposite direction. The opposite side of the quadrant 2 is quadrant 4. Staying on the ray of the angle 2 pi over 3, we would go out a distance of 2 units, most likely here. For F, the angle is 5 pi over 6, so we would stay on the ray 5 pi over 6. The positive r would have been in the second quadrant, but the radial coordinate for the point F is negative, so we would go to the fourth quadrant. And lastly, for the point G, the angle pi should be in the second quadrant, but with the negative radial coordinate. The opposite direction of the negative x-axis is the positive x-axis. This is G. Naturally, at this point, it is tempted for us to connect these points using a curve. As we go from 0 to pi, we also know the orientation of the particles that travels along the curve. But how do we know that the particles does not behave erratically between any the two given points? To be sure, we should sketch the graph of r equal to cosine theta minus 1 against the theta r axis. From this graph, we see that as theta varies from 0 to pi over 3, r goes from 1 to 0. The points on the polar axis would get closer to the origin because the distances are getting smaller until r is 0. As theta varies from pi over 3 to pi, r is negative varies from 0 to negative 3. The graph begins at the point A and moves toward the origin at theta varies from 0 to pi over 3. Since r is negative for theta from pi over 3 to pi, the curve continues into the third and the fourth quadrants rather than the first and the second quadrant because the negative r is in the opposite quadrant. So pi over 3 to pi over 2 is in the third quadrant. The negative r would move it to the third quadrant. Pi over 2 to pi is in the second quadrant. The negative r would move the point to the fourth quadrant until it reached the point G, which has the coordinate negative 3, pi. We only plot the points from 0 to pi, but cosine of theta is an even function. So using symmetry with respect to the x-axis, we can reflect this curve over the x-axis to obtain the points, and therefore the curve for theta from negative pi to 0. Using symmetry, the result is the graph of a limacon.